Okay, here we've got a question about probability. We're kind of expecting this to be a Poisson distribution, but why is it? Okay, well, for Poisson we need to be counting events in a fixed time or space. So where's the fixed time or space? Well, we've got a 5-minute period. Okay, we're counting the number of telephone calls, in fact, during a 5-minute period. In each case, these are all different 5-minute periods, but we're counting calls in 5 minutes. And oh look, we're given a min for how many calls we get in 5 minutes. So for this version, x, the number of calls, is going to have a Poisson distribution. We define that this way. We write PO brackets and then our no, it's not 5, it's 6 is our mean. Okay, we're not going to be using that figure of 5 at all, actually. We just observe that in each case we've got the correct number of minutes, so we can use this Poisson distribution. So we want the probability of there being no calls. Okay, so as with binomials, we draw the possible outcomes. Now, with Poisson, the difference is there is no maximum number of calls there could be, but in practice that doesn't change what we do at all. So the probability that there are no calls is just, we want naught, we don't want anything else. So in fact, our inclusion box just includes naught. So the probability of x being less than or equal to naught is what we want. So we set that up on the calculator in a similar way to when we did binomials. We go into 7. Okay, we go on to the second page and we want Poisson CD. We never use Poisson PD. We're going to do everything with Poisson CD. Okay, so using variable. Okay, now I've just got, unlike binomial, I've just got one parameter. I've just got 6. That's my value of lambda. Okay, so I fill in lambda is 6 and then the x value that I want is already set to naught. That's what I want. I want the probability of x being less than or equal to naught. So the calculator tells me that answer. So I just record that to 4 significant figures. Okay, 3 in the next 5 minutes. Well, once again, we've got reference to the time period. That's just reminding us that every time we need to check we are dealing with the correct time period. It doesn't change throughout this question. So I can still use the same distribution. Here are my outcomes, and I'm just interested in 3. I'm not interested in anything else. So my inclusion box has got to catch the 3. My exclusion box has got to get rid of these. So I do probability of x being less than or equal to 3 minus the probability of x being less than or equal to 2, and that's worth writing down. It's worth recording the separate probabilities. When x equals 3, I get this answer, and when x equals 2, I get this answer. You should write those answers down. You might use them again later, but certainly it shows your method of working. And then if I do that subtraction, got it set up here, we get this probability. Double underline it and move on. Now we want 2 calls. Again, it's a 5-minute period, fewer than 2 calls. So that means I'm not allowed to have 2 calls, but I can have these. So the probability in my inclusion box, I don't need an exclusion box, is less than or equal to 1 for x. X equals 1 on the calculator. There's my answer. Double underline it and we'll move on. Next one, we're doing more than 2. List the outcomes. 3 is more than 2, but 2 isn't, and these clearly aren't. So my inclusion box has to include everything. Okay, these go on forever, but I can include everything because I'm going to be doing 1 minus. And then I need to get rid of these pesky crosses. So my exclusion box is for all values of x up to and including 2. So I need to do 1 minus the probability of x being less than or equal to 2, which I've done already. So do the subtraction and you get 0.9380 to 4 significant figures. Good. All right. And then finally, what assumption is necessary? So I recognize this as being a Poisson situation because I was counting the number of calls in 5 minutes, events in a fixed time or space. But then the assumption level is, does it meet the conditions? So is the average rate of calls constant? Well, it tells me that it's a mean of 6 in every 5-minute period. So the average rate of calls does seem to be constant. But the other assumption is independence. Now, I'm going to have a bit of a rant here. What you will not get any marks for are things like these. If you say it is independent, you're not saying what is independent. There's no context there at all, so that's garbage. You wouldn't get any marks for that. If you try and be in context, but you say the numbers of calls are independent, that's utter rubbish. It's not the numbers of calls that are independent. It is just the calls, okay? So you have to say the calls occur independently of one another. You'd probably be all right with calls occur independently, which is short to write, but it's actually getting the context correct. It's the calls that have to not affect each other, okay? Numbers of calls don't affect anything. It's the calls that could affect each other, but don't, or we have to assume they don't. End of rant, but do make sure you get this wording right.